Okay.
Welcome everyone to this lab studies panel discussion. This panel is led by Prof. Alexei Korolev, and proceed with the discussions. Thank you.
Hello, everyone. We start from introduction of people sitting on the panel. I'm Alexei Korolev from Environment Canada, Environment and Climate Change Canada. My primary interest, microphysics of cold clouds, mainly related to mixed phase and secondary ice production, and also just interested in measurements, in situ measurements and instrumentation. Paul?
Hi, I'm Dr. Paul Connolly from the Centre for Atmospheric Science, which is based in the University of Manchester in the UK. In the past, I've researched and quantified primary ice nucleation in cloud chambers in the AIDA chamber in Germany, and also in the Manchester chamber in my centre. I've taken part in field projects measuring mixed phase cloud properties in situ from aircraft or from ground-based locations, and I'm also undertaking numerical modelling of mixed phase clouds. I'm interested in studying and quantifying secondary ice mechanisms in the laboratory, and I'm trying to improve models by taking advantage of laboratory data and comparing model simulations to observations.
Thanks. Birabel?
Hello, I'm Birabel Sinha from the Indian Institute of Science, Education and Research, and my main interest is aerosol. I work primarily using single particle techniques like scanning electron microscopy or chemical imaging techniques to study particle mixing state.
Thanks. Raymond?
Hi, thanks for the invitation. I'm Raymond Shaw from Michigan Technological University. I've been involved with lab work since the days of my PhD. Have various different scales and devices, from electrodynamic levitation up to now very actively involved with the pi chamber at Michigan Tech. Also involved with some theoretical and modeling work, although mostly riding on the coattails of others, I would say, in that regard. And I try to keep one foot in field work as well. So the Michigan Tech group is where the holodeck instrument was first developed, and that has now been transferred over to NCAR. Yeah, looking forward to this. Thanks.
Yeah, thanks. Zamin? You are muted.
Yeah, sorry about that. Yeah, hi, I'm Zamin Kanji. I am from ETH Zurich, and I lead the experimental atmospheric physics group here, primarily focusing on aerosol impacts on cold cloud formation. So looking at ice nucleation, and more recently at CCN work as well. So looking at warm clouds. My lab work interests have mostly focused on mineral dust and more lately soot impacts on ice nucleation, and in particular I'm more interested in aging processes, so looking at mixing state and atmospheric aging impacts on aerosol and its cloud forming properties. And yeah, thank you for the invite, and I'm looking forward to the discussion.
Thanks. Heike?
Yeah. My name is Heike Wex. I work at Tropos in Leipzig in Germany, and I started out as a field person doing aerosol work in situ, actually. Then I went into the lab examining hygroscopic growth, later on CCN, then ice nucleating particles, and specifically immersion freezing. Now I'm going a bit into the direction of IMP measurements in the field again, and yeah, so that's kind of the overview here.
Yeah, thanks. Shivsai?
Hello, everyone. My name is Shivsai Dixit. I am from Dr. Tara's group at IITM. I'm responsible for development of the fluid dynamics laboratory at IITM. I am a fluid dynamicist, basically, working in turbulence, boundary layers, and stuff like that. And primarily, we are concerned right now with the laboratory analog of low-level jets. There was a talk presented by my student, and we are getting interested into more into convection, and we have plans of also devising small experiments studying the effects of turbulence and droplets, cloud droplets. Thank you.
Yeah, thanks. Otmar, do you hear me? If you hear me, raise your hand. Oh, could you take your seat on the red sofa? Just if you go down south a little bit, next to Paul. Yeah, a couple clicks and you'll be there. I'm not sure if you are broadcasting.
I think you need to be on the sofa for the audience. Okay.
I only see my own screen right now. I'm not really in the room, or I do not see the room.
How can we figure out that Otmar is broadcasting?
Yes,
oh, yeah.
Perfect. Oh, you were there. 2 steps up.
Yeah, excellent. Yes. Oh, just go back. Yes, stop.
Yes, stay there.
Could you introduce yourself?
Yeah, sorry for being late. I had some trouble.
Oops. I think we lost connection. Okay, so I guess, hey, Otmar, you're back. Yeah.
Okay. Can you hear me now?
Yeah.
Hello?
Yeah.
Yes, we can hear you.
Okay, sorry. Yes, my name is Otmar Müller. I'm from Karlsruhe Institute of Technology and in charge there for the AIDA Cloud Simulation Chamber facilities, and also since some time very much involved in new infrastructure developments in Europe called ACTRIS. My interest is in cloud ice or aerosol cloud ice studies in the AIDA Simulation Chamber, and also in field measurements of ice nucleating particles and innovative new developments in this regard.
Yeah, thank you. At that point, I'm gonna share my screen. And so do you see my presentation?
Yes.
So we open this panel discussion related to the way forward regarding the future of lab measurements and how to kind of compensate this balance which is existing in cloud physics. So I would ask you to, by the end of when we open the floor for discussion, to speak about these items which are listed in the agenda: cloud processes to be addressed in lab studies, talking also about high and low priorities related to liquid clouds, mixed phase clouds, ice clouds, electrification, cloud chemistry. And of other items, different coefficients and constants to be studied, specified or clarified. What are the major requirements for the lab facilities? And what are the limitations imposed on studies of cloud processes in cloud chambers and wind tunnel, like effect of walls, particle wall interaction, residence time of particles, radiation effects, and so on. Instrumentation for monitoring, that's a very big item in cloud chambers and wind tunnels. and major instrumentation challenges, like, for example, measurements of supersaturation, non-intrusive measurements. And I want to just make a big emphasis the way forward in terms of how this facility should be set up. To start with, I will just bring up this cartoon how normally science should work. There should be just coherency between laboratory studies, observations, and theoretical descriptions. And after that, after any of those ideas and kind of ready to be released outside, they will go to main applications of cloud physics, such as weather predictions, aviation safety, climate simulations, weather modifications, and especially geoengineering, which is kind of becomes a popular topic, and people are aching to jump into it. But if we provide wrong information, you can imagine what might happen to the planet where we are all living. In an ideal world, there should be just a kind of equal contribution from all directions. So observations provide information which processes should be explored in laboratory studies. After that, it goes to theoretical descriptions to calibrate theoretical develop theories, and so it goes in a circle on and off, on just in all directions, and after that, just it goes outside. In the current status of cloud physics is like that. So laboratory studies were quite intensely developed in 50s, 60s, 70s, and after that it started gradually decline with a big kind of bias towards theoretical description, theoretical studies and observations. And at the moment they are pretty much disconnected. It's not really so. There is of course some ties, but it's not that what we want. And how should we proceed forward? So at the moment we just, there is a direction. We are just discussing what are the means and how this laboratory facility should be developed, whether they should be spread over universities or whether they should be just clustered in big centers, national centers or international centers. And so, for example, obviously they should be just include a wide range of static and dynamic cloud chambers and wind tunnels with a cascade of volumes from a few millimeters to thousands of cubic meters. It's a wishful thinking, but it's kind of you have to dream. With a controlled range of environmental conditions which occur in the troposphere, instrumentation to monitor the chamber environment, and trained research and maintenance personnel. And so it's kind of one of the things that it should be considered that those labs should be associated with government lab facilities because they may provide sustainable funding over course of 20, 40 years. Why so long? For example, this table shows that typical time scale to explore and bring to some sort of level of conventionally solved status takes decades, years and years and years. And if we just want to have another 50, 30, or 100 years to conclude, so for example, aggregation study of ice aggregation or diffusional growth of ice particles, so that's kind of probably we should stay here. But in my opinion, it should be just start pushing forward right now. And so here is a kind of recommendation for ICCP Commission have to generate a statement or document for national funding agencies like NSF, DOE, NSERC, German funding agency, CNRS, with recommendations setting up long-term programs for experimental studies in cloud physics. For that, we need to set a steering committee on experimental cloud physics, and I think it would be very useful to organize international colloquium on lab studies, with a regular, like monthly talks, similar to what we have now for like INP colloquium. General strategy, in my opinion, should be establish cloud physics laboratory centers associated in national labs. Historically, we have a number of good examples, like when prosperous university labs, they disappear after retirement of the champions of those facilities, like what happened with Roland Least laboratory facility or John Hallett. And maybe we should consider international lab facility and consider splitting specialization in areas of focus among other international and national labs. We can, of course, follow random specialization versus organized, but I think we have to synchronize our efforts collectively. And of course, there is a value in redundancy, and but just there is a tendency to pick up low-hanging fruits, and so that's the way. So at that point, I give I want Paul to proceed.
Thank you, Alexei. First of all, I want to direct the audience to the recent BAMS article that was published last year, which was a summary of a workshop to explore a large-scale aerosol, cloud and turbulence research facility. This article is a nice summary of where we're currently at, and it also talks about some outstanding and unsolved problems in cloud physics. I had planned to talk through the table, but I think in the interest of time, I'll move to the next slide, please. This is table 2, taken from the BAMS article, and it's a list of scientific questions in cloud-related fields that were identified at the workshop. And there's too many to go through here, but I have some comments on the following points. So the first one shown there, CCN or droplet activation. So many would think that, you know, we have dedicated cloud condensation nucleus counters, CCN counters, that can hold a constant supersaturation and measure the number of activated particles. But this is only one part of the problem. In reality, CCN activation can be buffered because of competition effects between the particles or because of kinetic limitations in the updrafts. And this has only really been shown using parcel models. To my knowledge, there's been no definitive experiment that measures this effect of composition between the particles. And furthermore, competition effects can also be important for ice nucleating particles, or IMPs. For instance, if you have IMPs and large amounts of hygroscopic aerosol in the same volume, this may result in a suppression of the activation of the IMPs in favor of the hygroscopic aerosol. Again, this has been shown in cloud parcel model simulations, but to my knowledge, there's been no definitive experiment to measure this effect. Next one, aggregation. Alexei mentioned it this morning. There are no laboratory studies quantifying aggregation efficiencies for snowflakes larger than about a few hundred microns, and this depends on habit. The effect of electric fields on aggregation, that may also be very important, and I think the field data shows this, the in situ field data. However, there are no laboratory measurements that quantify the aggregation efficiencies. There's only laboratory measurements which date back to the 70s, and these don't measure the aggregation efficiencies. They only measure the enhancement over the no electric field measurements, and these depend on the sizes and the number concentrations of the ice particles in the experiments, which weren't published. So it's impossible to see what the effect of that would be. Secondary ice mechanisms. Here there's been some much welcome progress on droplet shattering from the KIT group. Otherwise, there's a lack of studies since the 90s. And the droplet splashing freezing fragmentation, otherwise known as mode 2, which was presented at this conference by Rachel James, is another process that needs more attention. Ice-ice collisional fragmentation. This has been investigated in a few studies in the 70s and the 90s. These studies show that rimed particles are important for fragmentation. The Vardaman 1978 paper shows a strong sensitivity to the amount of rime on the particles. But the question is, when is a rimed particle a rimed particle? Or rather, what degree of riming is required for fragments to be produced in the collisions? We just don't know this, and it's difficult to put this into models. The Hallett-Mossop process, again, this depends on riming. So my comment would be, we can't just focus on large volume chambers, but the capability to develop smaller single particle experiments is also important. Next slide, please. Finally, the graphs on this slide show how important secondary ice may be in shallow cumulus clouds, and also to precipitation on the ground. Aircraft in situ observations show ice particle concentrations up to about 10 or so per litre on average, and this is shown in the top left plot on the right-hand panel. It's showing the ice concentrations, and they're up to about 10 per litre. And the cloud top temperature in this cloud is only -8 degrees Celsius, and there are no cedar clouds from above, no clouds at all above. The left plot shows a model simulation of the convection, so of this case, with LES. First of all, the plot on the left, the top left, is with secondary ice switched off. And here we see ice particle concentrations less than about 1 per litre. If we switch secondary ice mechanisms on, and that's shown the right-hand plot on the top, on the left-hand side, we see up to 5 per litre, maybe more, of ice particles. And in this particular case, precipitation on the ground is strongly affected, as shown in the bottom plot C, with the precipitation with this secondary ice mechanism switched on. Precipitation happens sooner, and it also has a much stronger peak. And this is our current understanding of the process, but we need to refine our understanding with more lab measurements, as I'll argue. And I'll end there. Thank you.
Thanks. Heike? Heike, are you up? You are muted.
Yeah, saw this. Oh no. Can you hear me now?
Yes.
Okay, so I start again. Yeah, good. I thought I'd summarize a little bit what we discussed this week and then go into the lab direction of lab studies. So actually on that sketch I made, we see on the left-hand side, like all the measurements, and here we see the problem we are facing. We are looking all at clouds and precipitation, and clouds are at a location that are hard to reach and they are constantly changing. And all measurements we can do either face the problem of low spatial and temporal resolution for in situ measurements with aircraft, for instance, or have these issues of remote sensing, no matter if from space or from the ground. So understanding of processes, as we learned, is difficult with these field measurements, actually. Sometimes it's possible, but we often get rather empirical information. So models on the lower right side, they want to include physics as good as possible, like really basic physics. That's also something that was discussed. So that has to come from somewhere. And for that, I drew that lab into the middle. It resembles the building I'm sitting in right now. And the thing that I found interesting, however, earlier that week, like experimentalists or measurement guys talked about how modelers should join experiments, field measurements, to see how that works, and vice versa. And maybe lab people were also implicitly included, but they were never explicitly talked about, which I think is interesting. Also, the statistics that Alexei showed this morning and mentioned again today, the decline in laboratory studies, I don't know if how strong that decline really is. I think that maybe this community here isn't reaching out to them very well. So maybe that is something we should also try to change in the future. There must be more lab studies out there than are presented here this week. Next slide, please. So what do we need these lab studies for? One thing that wasn't really mentioned is actually we need laboratories to calibrate the instruments that measure in the field. That's something very important, and you need to do this with high quality, otherwise you just measure something. Also for the development of new or small scale instrumentation, it's important that we have laboratory facilities. And then we heard about the determination of parameters that's needed, the examination of processes, and also we want to simulate parts of clouds that we can bring to the ground. So these are all things we need to do. I want to mention a few things that we really found in the laboratory. And with we, I mean the ice nucleating community, including us. And for instance, one thing that we really found in the lab recently was that it's potassium feldspar among all those mineral dust particles. That's a very ice active, the most active mineral dust. So that is some knowledge that has entered the modeling community to some extent, at least. On the other hand, we found out that macromolecules, proteins, and long chain sugars that are only a few 10 nanometers in size, they can act as INP and even detach from their carrier. We don't know yet if they fly around in the atmosphere, maybe they don't, but this kind of shows that the old Propacher definition of the requirements for an INP isn't correct. That knowledge hasn't entered the largest part of the community. And this is something where I start to wonder, how can we really spread information from the laboratory to the others, and how can that be used then in models or incorporated and not be forgotten? Another thing of that is like that we have understood also by laboratory studies the stochastic nature of ice nucleation, but we also know now that the singular description makes sense because it's freezing or ice nucleation. It's much more depending on temperature than on time. So all of these things, I mean, even if we find things in these few labs that are out there, how can we then spread the news? And so for that, conferences like that one are really good. But anyway, so next slide, please. There is a reason probably why people like to go to the field. I know when students come to us, they always want to travel, and lab work can be tedious, but it's reproducible. So yeah, you can take some time until you really get good results. If you go in the field, you have the data, you interpret it. The lab can tell us much more things in more depth. They might be more expensive than modeling. I'm sure that this is the case. And long-term funding is not always guaranteed. So we have two new setups here right now, one for secondary ice, the other one for turbulence, both only a few meters away from me. But I mean, we are really struggling to get the funding for that. So that goes back to what Alexei said earlier. And the last point is, how can we transfer new understanding to the community? I mentioned that one before. Yeah, so as said, it's good that we have conferences like that one for the transfer, and I will take this opportunity to thank Tara and her team for organizing this. I know how much work organizing a conference really is. And with that, I'm finished. Thanks.
Yeah, thanks, Heike. Otmar?
Yeah, hello again to everybody listening to this panel discussion. I would like to guide the audience a little bit to the European level of view of infrastructure development. And I put that together with my colleague Christina Höhler, who has a leading role in developing or establishing and implementing what we call Topical Center for Cloud In Situ Measurements as part of ACTRIS, which is a European level infrastructure project. And this has a lot to do with what Heike just mentioned, namely the development of standards and calibration measures and services for the community. Next slide, please. So, and my background is operating AIDA now for more than 20 years for cloud simulation work. And so this is a lot related to how we operate at our facility. I think really that it's not just the technical and instrumentation and expertise of the team that makes a facility unique. It's also the modality for physical, remote, and virtual access to these facilities to users and our collaboration partners. And we also had that to notice in the last 2 years of the pandemic situation. So next slide, please. There's a lot of initiatives going on in Europe for infrastructure development, and I have listed a number of them from the past. So your jump is project putting together for atmospheric simulation chambers. It also had partners for cloud process studies, and then there is this long term of development of ACTRIS projects. Now we have this ACTRIS distributed infrastructure project. Say a few words about that in a minute. And that has a lot to do with this long-term sustainability and operation of facilities and service centers and calibration measures and things like that. It has elements for reactive trace gases and aerosols, but also clouds, cloud in situ measurements and cloud remote sensing studies, and also simulation chambers and labs for aerosol cloud process studies. And there is some related projects which develop these measures and frameworks for access to our unique facilities. We now have the chance to extend and develop and in the next 5 years. And they are called ActriSim, then Atom Access, and some more also. So you can find more information in the respective web pages if you are interested in. So next slide, please. That just shows you a little bit more of the structure of the Pan-European research infrastructure ACTRIS, and I have noted here that it has these elements I already mentioned. So next slide, please. Here you see the number of facilities and partners which are involved, and on the right side you see the number of the service and topical centers, and you can notify maybe the one for clouds also, cloud in situ measurements and cloud remote sensing. And then the one for cloud in situ measurements is led by us under the leadership of Christina Höhler, together with some other partners. So next slide, please. And here you see at least some names of chambers which are involved and which now are receiving or have already received national funding to extend their capabilities. Like we at KIT have now received funding agreements to build a new IDA cloud simulation chamber. The LATSIS and LATSIS-T is also partially funded, I think, through these ACTRIS levels. Heike is more aware of that. And also the Manchester chamber and the CISAM chamber in Paris, they are also facility partners looking at cloud processes in the future in this framework of the ACTRIS. And you see here on the right side that this is just a combination of so-called observational platforms and these exploratory platforms, which are now combined and extended and improved for the capabilities, which also involves in the future cloud process studies. And it also includes mobile labs for cloud process studies, like UAVs and some other mobile labs and platforms, and also some other laboratories where unique experimental capabilities are already available and will be further explored and extended in the next 5 years of implementing this new infrastructure project. Okay, next slide, please. I think that was it, what I had. Yeah, this is just showing you that there's a lot of initiatives going on to really develop frameworks, at least in Europe, for access to these chambers for different users and from different areas like academia and also public sector and the private sector also. So that's all I had to show as introductory slides and statements. Thanks a lot for listening.
Yeah, thank you very much, Otmar. Very interesting. And at that point, we open floor for the discussion, and people from the panel and people from the audience, please speak up. People from audience have to come forward and take sit on the red sofa to be for broadcasting. And so here we start. So just I stop sharing. So you can raise your hand or just simply come forward and start talking. Raymond, do you want to say something?
Yeah, sure. Maybe I'll make a couple of comments. Maybe one comment, one philosophical comment, and one more concrete. I think one of the advantages of laboratory work, other than the obvious advantage that when you physically set up an experiment, all of physics is playing a role, whether you want it to be there or not. So if electrical processes are important, you will see them in the experiment. And it's unlike a numerical model where you know what you put into the model. So I think that's one of the important philosophies. But another one is setting up a laboratory experiment requires maybe a similar approach as in modeling, in the sense that we need to think carefully about how to simplify, or how to follow sort of a reductionism approach. How simple can we make a system without making it too simple? We want to be able to capture the essential physics, but not throw out too much. And I think that should be viewed as a strength of laboratory work rather than as a weakness. So often we get comments about, well, that's not as complex as the real atmosphere, or as a real cloud. And I think that's exactly the point of doing experiments, is to avoid that full complexity and to be able to zoom in onto aspects that we want to to explore. And then, of course, keeping a strong connection to the full complexity through observations and so forth. The more concrete aspect I wanted to bring up, just to sort of underscore what several of the speakers have said before me, or the panelists, that I certainly agree that there's a need for a whole spectrum of scales in laboratory work. So I think we've seen several examples in this conference of the really exciting results coming out of single particle, or experiments with small numbers of particles. And then, of course, there are larger chambers where we deal with whole ensembles of particles, and they simply address different aspects of physical processes that are important. The workshop that was referred to by Paul, one of the things that came out of that is, as we developed our list of processes, we asked the scientists in attendance to associate a range of scales with each of those processes. And we were surprised at the number of processes that essentially require reaching, let's say, meter or tens of meter scales in order to faithfully represent that physics. So examples might be collision coalescence, radiative transfer, even mixed phase relaxation processes. So that's part of the thinking behind developing larger scale facilities, but obviously not at the expense of smaller scale experiments. So just those comments for now, and I'm happy to answer any other questions.
Thanks, Raymond. So anybody else want to speak up? So you have to come up and sit on the red chair. So yeah, okay. So just I cannot read.
Many people raise their hands.
Someone raised their hand here in the audience.
I think Daryl Baumgardner raised his hand.
Yeah.
Yeah.
Yes. Alexei, can you hear me?
Yeah, I do.
Okay, so first I wanted to kind of reiterate what we started the discussion on Tuesday, that we really need new instrumentation for laboratory studies, because I love Heike's idea that labs are great for calibrating instruments, but the reverse is true. We need something new for the laboratory because it's a different environment, and you can't necessarily put an aircraft instrument into a chamber and expect it to do the same thing it would do. The other thing I wanted to mention is that people are finding new ways to use instruments. And Paul Field, your comment about CCN counters was quite interesting. Some of you might have seen a recent publication, I think in AMT, where they have come up with a new way of using the CCN counter, where rather than keeping all the particles down the center line, they basically open it up and they activate everything at once. And then kind of by the processing, they're doing more what you're talking about, Paul, which is to look at the interaction as well. So I think we need to be looking at creative ways of using the current instrumentation to possibly extract more information. And the final comment I want to make is we haven't talked anything about natural laboratories. And many of you have worked on mountaintops before. And it's not one size fits all, but you can learn a lot if you have a fixed facility on a mountaintop, whether it's at Storm Peak or in Puerto Rico or in in Germany or in Manchester or Great Dunfell. We've learned a lot in these natural laboratories, and I don't think we should count those out as another venue for doing these types of studies. So I'll stop there.
Yeah, thanks.
May I
George?
reply to?
Oh, yes, please.
May I reply to Daryl? Just 2 comments or 2 replies. Yeah, Daryl, thanks for bringing that up. So I think innovation is really important. And I did not mention that, but what we establish and implement in the framework of this ACTRIS, this distributed infrastructure, has also very strong components for innovative developments in support of that. And part of that can also be done in a way that what we develop as topical centers or service centers for calibration and intercomparison and things like that can also be used by the public sector and industries to test instruments or calibrate instruments if needed. Just want to mention that. So we are aware of that, but it's still maybe something that needs to be further developed and then improved in a way, also from at the edge of us as scientists and operators of facilities. And the second part, I agree. This is also what you said about mountain stations and intensive field campaigns in observatories. I would also fully agree, and it's also partly done and considered in the framework of this ACTRIS network.
George, I saw you just coming up. Yeah, yes, please, George. George, can you speak up?
Yeah, sorry, I was muted. I just want to point out that one facility won't solve the problems because, for example, if you want to calibrate aircraft instrumentation, you have to have a high-speed wind tunnel and icing wind tunnel. If you want to simulate the collision of a large drop with a small drop, you probably have to have a vertical tunnel where the drops reach terminal fall velocity, and the same thing goes with hail. So you're not going to get one facility that does everything. So it has to be a spectrum of facilities. That's all I can comment.
Thanks, George. Yeah, that's exactly what we are discussing now. So we're considering that this facility should have a cascade of different cloud chambers and tunnels, vertical, horizontal, with a different speed, with a different pressurized, with a wide range of temperatures and so on, to just simulate the conditions in tropospheric clouds. And so this is quite expensive, and that's why we are talking about this is a big investment which should be decided on a national levels. Otherwise, it will be scattered at different facilities of different size over just across countries and across the world at different universities, organizations, and how effective would it be? So far we worked on this level. And I really kind of admire what Europeans are doing. So that's really kind of the way to address cloud physics issues.
Heike here. I would add something here, or not add. I would repeat something that I said earlier, and I think that I really understood maybe today and through your talk, Alexei, this morning, that maybe people attending ICCP are not necessarily those people working in laboratories. And you are right, it's on a decline and it's all expensive, and there can be improvements in laboratory studies. But I also think maybe we should really try as ICCP to reach out more towards people already doing some of the research. Because so far, if Ottmar wouldn't have said that, ACTRIS and ICCP were two separate things in my mind, because that's also more about aerosols, but it includes clouds as well, and the chambers. And yeah, so I was wondering, you proposed that, Alexei, that there could be like a colloquium, maybe a monthly or bi-monthly organized colloquium by ICCP that kind of circulates through the different fields, and maybe we can really try to do something. I mean, I know my schedule is quite full already, but I don't know, maybe others have thoughts on that. Ottmar, you raise your hand.
Yeah, may I just a little bit argue against you? It's exactly this round of discussions and conferences and meetings where we need to talk together and strengthen our impetus and our input to such infrastructure projects like Actris, because I think they have that background. And you're right that in the past maybe it was more focused on trace gases and aerosols, but now we have the chance to really make strong arguments about a need for more of these aerosol cloud process studies and lab studies also. And why not there in such large frameworks to really have good arguments and have a good, strong community in the back. And for developing further also the components of cloud measurements and cloud in situ aspects in this Actris framework, we really need a community background and a community contribution. I can also only invite everyone to be aware of that. That's one of the reasons why I also put that point a little bit more in the focus of my contribution today, because we really need a community contribution when we start to develop more standards, more calibration measures, new instruments, new collaborations, new activities and things like that. There's a lot to do, I think, still, and there's a strong need for. I think we are all convinced of that, but we just also need the support and the collaboration among each ourselves. And good arguments also. So that's just want to add that. Otherwise, you're.
Can I answer to Ottmar?
Sure.
Yeah, you are right, Ottmar. But however, when I think about this, we have this discussion today, and the next ICCP will be in 3 years already. But that is probably too late for what you are planning. So I think there needs to be action between the conferences, and of course there's like the ICCP, the commission itself, but also I wonder how I was struggled by how many people do not feel connected to the ICCP community that came out on Wednesday morning in that talk. And I have to, I'm a bit more connected than others are, and I still see what they mean. So we should improve that, and anyone who has ideas can maybe write an email to Greg or Martina or myself or whatever. And thanks.
I made the next chance for us to be visible is of course the ICNAA. Maybe there it's even closer to us as people working on the smallest scales and on the nucleation problems. Yes, but I think also the ICCP committee could also be a perfect, great platform to really also mediate what we here discuss, future needs and new initiatives.
Yeah, that's a very good idea. And there is a question from Nandakumar.
Yeah, it's not a question. I'm one of the panelists, actually. I'm sorry for the delayed entry. I got stuck at the entrance. Myself, Nandakumar from Mahatma Gandhi University, Kottayam, Kerala, India. I'm an associate of Dr. Tara Prabhakaran. And I'm basically doing the aerosol analysis using high resolution transmission electron microscope and EDS analysis. So there's a couple of problems I have faced with the aerosol analysis using electron microscopy is that the transfer of the sample which you have collected to the grid for a TEM analysis. So probably we can make use of some of the inbuilt grids when we perform the experiments. Then it is easy for us to do it directly on the grid. Otherwise, we have to find a typical solvent to dissolve and analyze that. And we also do the elemental analysis using X-ray dispersion analysis. And it is the problem what we have faced is the overlap of certain peaks. So what I intend to do is that I can make use of the laser-induced breakdown spectroscopy to supplement the data or to support the data what we have obtained through electron microscopy. And we have a very good experimental setup for LIPS, laser-induced breakdown spectroscopy, making use of 1 joule Nd:YAG laser and a spectrograph and ICCD camera. So we will be able to differentiate the peaks from different elements, because all the samples what we collect normally composed of organic and inorganic materials or elements, then it is very difficult to differentiate at times. So probably if somebody else has some other novel ideas, that would be more welcome, so that we'll be able to analyze the samples more effectively. Thank you.
Thanks, Paul. Is it your hand? It's hard to understand to Raymond's.
Yeah, my hand.
Oh.
Just to pick up on the comment by Heike, and I think you're absolutely right about there's been a lot of success between people making lab measurements and that information being fed into modeling studies. You mentioned the K feldspar, the potassium feldspar. You mentioned the macromolecules, and I think you may have mentioned bioaerosols as well. This activity is ice nucleation, ice nucleating particles, and there's a huge amount of work being done. And over the last 20 years or so, I think I've not done the statistics, but if you look at the number of papers published in that field, it's enormous. But to take secondary ice as an example, secondary ice mechanisms, how many studies take laboratory data? So based on laboratory data in the last 20 years, and are able to put that data into models to improve models. And I think it's only one or two in the last 20 years. And when we look at in situ data, when we look at aircraft in situ data, we always talk about secondary ice being important, but I don't see huge laboratory activity. I don't see a huge laboratory activity outside, say, KIT, for instance, with the droplet fragmentation papers. So I think that's a potential area where we need to look at. I think there's been great success in studying ice nucleating particles, and if we can do, we should try to emulate that in our studies of secondary ice, for example. But yeah, that's the comment I wanted to make. Leave it there.
I want to add to Otmar. I think it's very important to stimulate exchange between modeling community, in situ measurements, and laboratory study, because so far it's not exactly bubbles, but it's a good kind of level of isolation between those sub-communities. And we need to sit together and talk, and what is important, what just the most recent findings and how it may affect cloud processes. Is we still have a number of dark corners in cloud physics, which should be where light should be put on, and for that matter, we might need a steering committee on those cloud. Laboratory studies in cloud physics and colloquium to share ideas, inviting people from numerical simulations and observations to navigate what to look and what to look at, let's say in real clouds, in situ observations, or just remote sensing, whatever, and what should be put efforts in order to kind of develop a theoretical description. So I think that we should seriously consider that direction. But we need a champion for this. We're all busy, and somebody has to step forward and be brave enough.
Is someone using machine learning platforms for simulation studies? Someone in our group?
Greg, you want to speak up?
Yeah. Yes, thanks. Can you hear me okay?
Yes.
Okay, well, I'd like to make a point. One thing we can do in the new commission is we certainly can look into some monthly meetings, monthly seminars, and bring these communities together. And certainly we're taking notes of that. And I think that is something to do, based on also our discussion of the modeling group on Wednesday, to bring these groups together on common problems so we get more discussion. But I also want to point out that there's one more opportunity I think that we have not been really taking advantage of. In that, yes, it's true that the next ICCP meeting will not be until 2024, but almost every year there are meetings with cloud sessions involved. So for example, in 2023, there's going to be the IUGG meeting in Berlin. And right now, within the next month, we have to formulate some special sessions that we will propose for that meeting. So it'll be great to put some of these ideas together and try and get not only a workshop at some of these meetings before or after this meeting, but also to have some focus sessions where we can bring these communities together in a common session so we can have the 15-minute talks, which can serve as the basis of some of these discussions that we'll do after the workshop.
May I just add, there's also some other initiatives, of course, going on. Some of you are involved anyway, you may know, but for instance, in September, there is a Cloud Simulation Chamber workshop organized by Luding Su and his colleagues from Beijing Weather Modification Office, which is the next opportunity, at least for the Cloud Simulation Chamber people who are working on that scales, to meet and to discuss. And I totally agree to Greg that there's opportunities with all these other conferences and sessions. And also next year, the ICNAA will be a good platform, of course. And I also like these monthly colloquia now organized. Every month. That's also great. Yeah.
Jan Henneberg. Jan, you looks like you are muted.
Oh, sorry, I raised my hand. Sorry.
Yeah, you want to speak up? If not, Lulin, I saw that you rose your hand.
Have a thumbs up because thank you, Otmar, for advertising that. And I think, as Alexei mentioned, it will be, we need someone, or at least some ones, to organize and to plan, and for a lot of these coordinations. And I do think it's very, very important, but very hard. And maybe for the next several lab-related workshops or discussions, we should put some efforts to see, to discuss how we can better move on this kind of an initiative and international collaborations. Just a thought that in the future we should keep it constantly on the discussion item. And maybe at a certain point we will have an initiative that can get more people involved and better organized.
Yeah, thanks. We are close to the end of our panel discussion, so we have 3 minutes left. So anybody wants to make any statements?
I was thinking of making a sort of statement that maybe kind of sets the cat among the pigeons. So we have looked at rainfall simulations, for example, in the WRF over our region. And I mean, the way it looks like is that right now the overall processes are very dominated by orographic forcing. But what seems to be happening based on the statistical observational data is a lot of rainfall bias over urban heat islands. And that may not necessarily be a problem of the cloud physics not being good in the model, but rather the land surface heat contrast not actually feeding into anything in the cloud physics. So, I mean, maybe we also need to look at some of the processes, how the clouds actually get into the model and where they are not, but they should be. Because that seems to be driving extreme rainfall over urban regions, that thermal contrast and the convection that is statistically more intense over the urban area.
Yeah, thanks.
A comment on, can you hear me? Yeah. So maybe just one thing to think about also is a kind of workshop where modelers and lab people can talk together. We have a modeling workshop at the start of the ICCP but should that also be, invited lab people to participate in that sort of thing?
Yeah, that's a very good idea, Paul. So I think we have to just set this inter-sub-community exchange stronger than what we have now, because kind of break those walls which do exist. And just one of my proposals, so we have to wrap it up, our session, and is to ask the ICCP Commission to develop a strategy about this, and maybe identify champions who will take over, and to proceed. Otherwise, it will naturally die, because all people are busy, and somebody has to shake the community and identify directions where to go. I think at that stage we close our panel discussion, and somebody from the CCP Commission Greg, you wanna identify the next event at the ICCP, or? Greg, you are probably muted.
I think I have to come up to the red sofa to get the talk. So can everybody hear me now? Yes, okay, good. So I think we are going to move into the closing ceremony now. So for that, to start the closing ceremony, we are going to go to, I think Thara and Andrea are going to lead off, and then we'll eventually get to Daryl and myself as well. So maybe all people participating in the closing ceremony can come up to the red sofas now. And while they're coming up, I think I want to thank Alexei and his crew and all of the panel members. I think this was a very great discussion that we had, and the commission has taken good notes on a lot of the recommendations that have come out of this discussion. And I'll give a wrap up at the end of the closing ceremony on future directions, but be assured that your voices have been heard.
Can I add something? Because I have the feeling that you get it wrong. Because the closing ceremony is on AirMeet and not on Gather.
Oh, okay. Thank you. Okay, so we need to go to AirMeet then.
Yes.
Okay, so everybody can leave then and head towards AirMeet.